Hello learners, welcome to Education Online program. I'm teacher Willa Lucia. So in our previous lessons we've been talking about expansion of matter, the thermal expansion of matter, where we looked at the expansions in solids, in liquids, and also in gases. So as we said in our previous lesson, today we shall be looking at the gas laws. So when we look at gases, they have got properties. Those properties we observe them using our senses. For instance, they have the volume. Gases have got, there is pressure, the exact pressure. This is also like a property of a gas. So we have the pressure. So you see that there is also the mass. So we also have a property of temperature on the gases. So you see that because of this, they have got a relationship in between them. The temperature, the pressure, and the volume. So these relationships here have been combined into what is known as the gas laws. So you'll see that these gas laws here will show you the relationship between pressure. It will show you the relationship between either pressure and temperature. So as we go on, we shall be looking at those relationships. So there are basically three laws we're talking about here. We have the first law as we call it the Boyles Law. So we have also what is known as the Charles Law, and then we have the Pressure Law. We shall be looking at all these laws one by one. So for today, we shall start with the Boyles Law. So how do we get this Boyles Law? You see, from the name Boyles alone, this is already a name of a person, Boyles. So in around mid 1600, there is this scientist called Robert Boyle. He studied the relationship between volume and pressure. So how did he do that? He made sure that this gas is actually confined. During his study, what he kept constant at that process was the temperature on this gas. So he used the ideal gas. So during that his study, he found out that when he gets the product of pressure and volume, it keeps giving him a constant. That is when he maintains the pressure constant. So this law here has been it has been called the Boyles Law just in his honor, because he was the first one who actually started the relationships between this pressure and the volume at the constant pressure. So we state our Boyles Law as it is stated as the volume of a fixed mass of a gas is inversely proportional to its pressure at constant temperature. So we see that from our statement there, the volume of the gas is not directly, it is inversely, meaning that when there is increase in the pressure of the gas, there will be a decrease in its volume. How is that possible? We shall see when we are trying to carry out an experiment to verify this law. So mathematically, we shall see that we are saying that our pressure here does not respond directly to the volume changes, but then inversely. So we shall have it is equals to 1 over 2. Because if 1 over V, because if you have it this way, meaning that this one here, as it goes up, this will be going downwards. So we want to eliminate that by introducing an equal sign. So we shall have our pressure, which will be equaling to what? To K. This K here is our constant of proportionality, but then the K is multiplying 1 over V. So we shall have our P is equals to K and then 1 over V there. But remember, we are saying it is at constant temperature. So we try to make our constant of proportionality the subject. We shall have we shall cross multiply thereby we multiply both sides by the volume of this gas. So we shall have our P multiplying it by the volume will give us the constant over V, and multiplying it again by the volume. This one will cancel that volume. So we shall have our P times V, which is equals to K. So that means that our P, our pressure, the product of pressure and the volume will give you what? A constant. Because here the K we are saying is the constant of proportionality. So if it gives us a constant here, what is the constant from our statement there? We are saying that we kept pressure, we kept temperature constant during this study. So that means that here our constant is the temperature. We shall have our P, V is equals to the T. But then at varying when it is now you're using different gases, that means that every time here at that same temperature, you'll be getting the same product of the pressure and volume. So we shall have, in case we have the pressure 1 and then we have the volume of a certain gas at constant pressure, and then the same pressure is also kept constant when studying the pressure of another gas, we shall have it is equals to P, the pressure 2, and then the volume of that gas. So this is how we mathematically express the Boyles law. So let us first try a question using this expression before we go and see how to verify this Boyles law. So our example would be like, it's saying that the pressure of a fixed mass of a gas is 5 atmosphere. When its volume is 200 kg 200 centimeters cubed. Find its pressure when the volume Roman 1, when its volume is halved. So we have a second Roman that when the volume is doubled. So what if now this volume is increased? Volume is increased by 1.5 times. Provided temperature provided the temperature is constant. So with this question, with our example here, we actually want to see how we can get the volume of this gas using the mathematical expression of Boyles law. So let us try to summarize our question here. So our question is telling us to find the pressure. The pressure first of this gas was given to us as 5 atmosphere. So we look at this ATM. I am giving it as an abbreviation for atmosphere. So we have the volume there. This is the first volume before us compressing the gas, which is given to us as 200 centimeters cubed. So they want us to find the pressure 2, which is the second pressure after the second pressure exerted on our gas. But then they're saying we find this pressure when this volume 200 here is being halved. So halving it meaning that we have to multiply it by 1/2, or we can say it by 0.5. So what are we going to get? That will give us the second volume of this gas. So we shall have our V2 is equals to that is going to give us 200, and then we are multiplying it by 1/2. If you do not want to multiply it with the fraction form, then you can get the 200 and divide it by 0.5. So we shall have it as, and all of this is in centimeters cubed. Our second volume will be, when you get 200 and multiply it by a half, we shall get this one will go here once, and then we shall have it as 100 centimeters cubed. So this 100 centimeters cubed gives us the second volume of the gas after it being compressed. So what will happen is we apply our mathematical formula of this Boyles law, where we shall have our V1 is equals to P2 and then the V2. So if we have it like this, you now come and substitute your values. So how shall we put our P1 there? The first pressure is 5 atmosphere. So we shall have 5 multiplying it by the volume, which is 200. Then at this point here, we want to find this pressure, which is P2. We don't know. When we reduce the volume of this gas to 100. So when we multiply it like that, we shall have, if you get your 200 and multiply it by 5, what shall we have? So we shall have here by 0, and then 0 2 times 5, we shall have it as 10. That means that 2, when you multiply 200 by 5, you shall get 1000. So this will give you 100 P2. So you divide through by the coefficient of this second pressure, which is 100, and divide it by the coefficient of this pressure. So this one will cancel out. We shall have our second pressure, which is the P2, is equaling to, when you divide 1000 by 100, what shall we have? We shall have it as 10. But then what was given to us as the SI unit, we have it as the atmosphere. So that means that when the volume is being halved to 100, the pressure of that gas will be increased from 5 atmosphere to now 10 atmosphere there. So the question Roman numeral 2 is telling us that what if the volume of this gas is doubled? What will be its pressure? So what if it is doubled now? We shall have our volume 1 still remains as 200 centimeters cubed. So we shall still have our pressure, the first pressure giving us 5 atmosphere. But in this case, we are now doing what? We are doubling the volume. So doubling the volume meaning that we shall have 200 plus 200. So we shall have our second volume now is being increased to 200 plus 200. This is in centimeters cubed. So now if we have it like that, we shall have our second volume to give us 400 centimeters cubed. All this process is done at constant what? At constant pressure, at constant temperature. So now if we have like that, what will be our pressure? So our pressure we still maintain. We say that the pressure of a fixed mass is directly inversely proportional to its volume, but then we are keeping the temperature still constant. We shall have our P, the pressure, and then the volume. Keeping it constant, we shall have the product of this second pressure and the volume also. So we shall have our P1 still remains as 5 atmosphere times the volume of that gas still remains 200. But then the volume is later changed to what? To 400. So we shall have our 400 and multiplying it by the pressure. So we shall have our 1000 equaling to 400 P. So now you divide through by the coefficient of the pressure, which is 400 on both sides. You divide it here by 400 and divide it here by 400. So when this will cancel out, then we shall have our second pressure there to be equaling to the second pressure will give us what? This will cancel and we'll go with that. We shall have this. 4 will go into 4 once. And then how many times does 4 go into? Into 10. You see that 4 will go into 10 2 times because 4 plus 4 is 8. So if it goes 2 times, what will be the remainder? So we shall have it as our 2. Our remainder there is going to give us, will give us 2 as the remainder. So we can have it as 2 whole number. We shall have it as 2 whole number, then the remainder, which is 2, dividing it by the 4 here. We shall have it by the 4. So that will give us the atmosphere. So meaning that when you double the volume of this gas, what will happen to its pressure? Will its pressure still remain the same as 5 atmosphere? It does not remain the same as atmosphere, but then when it will come back to 2. So if you have it here as 2, meaning that the moment you increase the volume of the gas, the pressure is reduced. So when you also increase the pressure of the gas, what will happen to the volume? The volume will also reduce. So this is how this happens when we increase the volume. So what if the volume is now increased by 1.5 times, provided the temperature is kept constant? What will be our pressure? So let us see. So this time round, the pressure of the gas at the first point was 5 atmosphere. So from there, the volume was 200 centimeters cubed. We do not know the second pressure when the volume is being increased by 1.5. So this is what we want to find when the volume is now of the same gas has been increased by 1.5. So to increase this volume here, we shall have the first volume, which is being given, that is the 200. So what do? We are saying we increase it by 1.5 times, so we shall multiply it by 1.5. So this one will give us the centimeters cubed. So what do we have? We shall get our V2, which will be equaling to, this one here is a mixed fraction, so we can change it to proper fraction, then multiply. We shall be having it as 200 times, we're going to get 2, multiply it by this one, and then add that 1. So we shall have our 2 times 1 plus 1, but the whole of this is over 2. We are finding it in centimeters cubed. So we shall have our V2, which will give us 200 times, if you get your 2, multiply it by 1, we shall still have 2, and then we add 1 to it to make it 3. So we shall have it as 3 over 2. So this time round we are multiplying, we are taking our 200 into the bracket. So we shall have 200 multiplying it by 3 and dividing it by 2. So if you have 200 things and you multiply it again by 3, so what will give you? You'll be having 6. You'll be having 600, but then you're still dividing it by 2. So you have 600 things and you want to give to 2 people. Each one will be receiving what? Each one will receive 300. So our SI unit here is centimeters cubed. So now this is the volume now. What if your volume has been increased from 200 centimeters cubed to 300 centimeters cubed? What will happen to the pressure? So to find out what will happen to the pressure, let us apply Boyles Law again, which says the product of the pressure and the volume will give us a constant. So our first pressure there is 5 atmosphere. We're multiplying it by the volume, which is 200, and then it is not multiplying here. We are now taking it to the other side, which is equaling to the second pressure is what we want to find when the volume is being increased to 300. So when you multiply your 5 times 200, you will get 1000, which will give you, multiplying any letter or unknown by a number will give you the number as its coefficient, and then you have the letter, the unknown there. So we are going to divide through by the coefficient of the pressure, which is 300, and then we divide through by 300. So at this point here, our pressure will be given to us as this one will cancel with that, this will go with that. So how many times will 3 go into this? It will go once. How many times does 3 go into 10? We see that when you have 3 plus 3 plus 3, 3 plus 3 is 6. You add another 3, you will get 9. So if it goes into 9, if into 10, 3 times, what will be the remainder there? Our remainder will be 1. So we shall have it as 3 whole number, 1 over 3. Or you can write it in decimals, which will be P2 will give you 3.3 recurring, or you can just put 3.33. So, but then our SI unit is still the atmosphere. So, what do you observe in our calculation? Let us start from the first point here. At this point here, what happened to our volume? When we reduced the volume of this gas from 200 to 100, and then we try to find out the pressure of the gas, look what happens, that the pressure has been doubled. So when you reduced it here by half, we are adding the pressure by half also. So that's why you see that there is a difference here between this pressure and the second pressure, because our Boyles law says that these two they don't move directly with each other, but they move in an inverse way. Even though you come to our second calculation here, when we increased now our volume from 200 to 400, what happened to the volume? The volume was reduced also. So if you also came here, it also happened the same way. We tried increasing the volume of the gas, and what happened? The pressure reduced. So this one is telling us that during this study, it was true that whenever you increase the volume of a gas, you will be reducing the pressure of that gas. So this one is verifying for us the Boyles law. So with this, we come to the end of our lesson. In our next lesson, we shall be looking at experiments to verify this law. What experiments do we need? Whether at home, if you can do it, so or you want to do it in the scientific lab, we shall all find that in our next lesson. Thank you very much for attending.